Hello everyone. Today we are going to see cbse class 10 chapter 4 carbon and its compounds. So we'll just see what carbon is. Carbon is represented by C, and every one of us know what carbon is. What is its atomic number? Its atomic number is 6. That means there are 6 protons inside the carbon's nucleus. Also, the 6 electrons around the nucleus. So we will see some of the peculiarities of carbon, how the bonding of, or how the chemical nature of this element is special compared to other elements. There are a lot of carbon compounds in nature, unlike any other elements compounds. Number of carbon compounds is very high. So first we will see how the bonding of carbon is in these carbon compounds. So we have learned about ionic compounds. What are ionic compounds? Ionic compounds are compounds that are formed between, for example, Na plus and Cl, how they are going to completely transfer to the chlorine atom. Then only sodium chloride can be formed. Or if we take sodium chloride, sodium will act as a positive ion and chlorine will act as a negative ion. So these kind of compounds are known as ionic compounds, where there is the elements are appearing as ions. So here sodium is appearing as a positive ion or a cation, and chlorine is acting as a negative ion or an anion. So these are known as ionic compounds. So if we check the physical properties like melting point and boiling point, we can see that these ionic compounds, all these ionic compounds have very high melting point and boiling point. Melting point and boiling point is a direct measure of the strength of the bonds between these ions. High melting point means melting point is high or boiling point is high, meaning the direct meaning is that the bond, the NaCl bond is very strong. So that is in the case of ionic compounds. And if we see the compounds of carbon, for example, acetic acid, chloroform, ethanol, methane, these all have carbon in them. These are carbon compounds. When we check the melting point and boiling point of these compounds, we can see they are not very high. See, as for acetic acid, the melting point is 290, boiling point is 390. That directly implies that for carbon, the bond is not ionic. Carbon is not forming ionic bonds. So there's another kind of bond that is present in the carbon compounds. Also, conductivity measurements. Conductivity measurements means how electricity is conducted through this solutions is measured. So if there is ions present in the solution, like ionic compound solutions, if we take a solution of NaCl, sodium chloride, there will be Na plus and Cl minus ions in the solution. So because of this ions presence, the electricity passage is very high in the case of ionic compounds. But when it is measured, the conductivity is measured in the case of carbon compounds, it shows that the conductivity is less, meaning that there is no free ions are there in the carbon compounds. So these measurements, being melting point measurement or boiling point measurements, and also the conductivity measurements, proves that carbon compounds are not formed by the formation of ionic bonds. In other words, there is no transfer of electron happening in the case of carbon compounds. Now we'll see how bonding is happening in the case of carbon compounds. So we have already said the atomic number of carbon is 6. There are 6 protons as well as 6 electrons for carbon. So how is the electronic arrangement is for the carbon is? In the K shell, how many electrons are there? The maximum possible number of electrons is 2. So K shall have 2 electrons and L shell will have 4 electrons, since there are 6 electrons around the nucleus for a carbon atom. So we all know all the elements will try to attain the configuration of the nearest noble gas. So what all are the nearest noble gas here? Helium and neon. So helium has an configuration like K level has 2 electron and neon has K has 2 electron and L has 8 electrons. So that is the configuration of neon. So carbon can either have this configuration, electronic configuration, or this electronic configuration, or it could gain 4 electrons forming C4 minus ion. Then it will have a configuration of that of neon. But it is very difficult because the number of proton is 6. For that nucleus to accommodate a number of 6 plus 4, 10 electrons is very difficult. For 6, because 6 protons cannot hold that much of strength of 10 electrons. So it is very difficult for this anion to form. So the next possibility is it could lose 4 electrons forming C4 plus cation. But for removing electrons from shells progressively will require more and more energy. So it's very difficult to remove all these 4 electrons from the carbon. So these two possibilities are not happening in the case of carbon when forming bonds. Then what is happening for carbon is what we are going to see. So another kind of bonding is happening in carbon, that is known as covalent bond. Covalent bond means there is sharing of electron between 2 atoms. So that is the bond in all the carbon compounds. So this is also observed in the case of chlorine, hydrogen gas, nitrogen, etc. And for carbon compounds also. For example, we'll take these 4 samples. So for hydrogen has only 1 electron. So when they are forming a hydrogen molecule, each hydrogen atom's 1 electron is shared by the other hydrogen. So in total, this hydrogen molecule will have 2 electrons, and these 2 electrons are common to both these. And this kind of bond is known as covalent bond. And this bond is not as strong as ionic bond. For oxygen molecule, it's like this. Oxygen has 6 electrons in the valence shell. Oxygen has an atomic number of 8, O8. So K shell has 2 electrons and L shell has 6 electrons. And while forming oxygen molecule, two electrons from one oxygen is shared with the other oxygens, 2 electrons. So these 4 electrons are common for each oxygen atom in the oxygen molecule. So if we are counting the electrons, this oxygen will have 1, 2, 3, 4, 5, 6, 7, 8 electrons around it, satisfying the octet for stability. And this oxygen also will have 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8 electrons around it. Similar is the, so since 2 electrons each are being shared, the bond is a double bond. Here in the case of nitrogen, the number of electrons shared is shared or used from one nitrogen is 3, and the 6 electrons are common for both this nitrogen. So this is a triple bond. 3 covalent bonds are there in between nitrogen. So what is the peculiarity of this covalent bonds? Covalent bond is not strong as that of ionic bond, less strong, and sharing is happening. There is no ion formation. Less strong, no ions are formed. Ions are formed when electrons are completely transferred. Since this kind of molecules are sharing electrons, there is no formation of cations or anions. And coming to this carbon compound, that is this carbon compound, methane. This is what happens. We have seen that carbon has 4 electrons in the outer L shell, and each electron is shared between, if you are counting the electrons, carbon has 1, 2, 3, 4, 5, 6, 7, 8 electrons around it, and hydrogen has 1, 2, and each hydrogen has 2 electrons around it. So this is a stable compound. So the bond in carbon compound is covalent bond, which is less stronger than the ionic bonds, and no ions are formed. Sharing of electron is happening in the case of covalent bonds. And now we see an important property of carbon. Carbon can form several allotropes. Allotropes are different structural forms of the same element. Based on the difference in arrangement, these allotropes can have different physical properties. For example, diamond is an allotrope of carbon. It's entirely made of carbon atoms. So graphite is also an allotrope of carbon, which is entirely made up of carbon atoms. Also, Buckminster fullerene molecules are also allotropes of carbon. These all have different physical properties. We know diamond is one of the strongest material in the earth, and it's very rigid. It's very strong. In the case of graphite, it's not strong as that of diamond. It's like layers. It can be easily made into powder and all. So even though both all these allotropes are made of carbons only, they have very different physical properties. Also, the conductivity. Graphite has very high conductivity, where in the case of diamond, it is not conductive at all. So in diamond, carbon is attached to 4 neighboring carbons by a covalent bond, and it's a very rigid, strong structure. In the case of graphite, it's kind of a layered structure, a hexagon. A sheet of carbon hexagon is placed on top of each other. Means for fullerene, there's hexagons and pentagons. So this is one of the peculiar characteristic of carbon. They can form allotropes. So I hope the class about bonding in carbon is very clear to everyone. And we will see the next topic on the next video. If you have any doubts, comment below the video. And thank you for watching. Happy learning.